5 or Q is not equals to 5. Yeah. Okay, any questions? No? Then can you please submit your homework to the front? Come in. Ayo, 1 second. Anybody else and I will submit? Alright. I counted, let's see. So 24 students in our class, right? Who else never submit? Anybody else? Oh, sorry, I thought Charmaine's one is here. I'm sorry. I didn't know, sorry. My bad. Okay, no Venn diagram yet. Okay, so the last time round, I introduced to you what a Venn diagram is already and introduced to you how to draw a Venn diagram. And then also we talked about certain locations for use in Venn diagrams. Okay, so let's continue talking about that topic first. Let's first look at exercise 1B question 8, where we are given 2 sets. Okay, so in exercise 1B, question 8, we are given H to be a set containing rational numbers and then I to be a set containing all the integers. Okay, so the question is asking whether I is a proper subset of H or not and asking to explain. So what do you think? Is I a proper subset of H? That means in other words, are all integers rational numbers? What are rational numbers? Any ideas? What's rational number? What's a rational number? Yeah, ask you back. I'm sure everybody, there are 24 of you in the class. Okay, you one person don't know, surely somebody else will know, right? So what's a rational number, guys? Yes, Amanda? Don't know? What's a rational number? What do you think? Huh? All angles? Not endless. That's a strange definition. What are rational numbers? Answers? Any ideas? Or no ideas? Non-recurring. Wow. Where do you all learn all these definitions from? Rational numbers are simply your fractions. Yeah. Any number that can be written as a fraction is a rational number. Okay? So be expressed in the form m over n, that means a fractional form, but then m and n must be integers. Okay, so we don't have decimals in the fraction itself. Okay, so that is what we see as a rational number. So now, can you tell me whether integers are rational numbers or not? Who agree that integers are rational numbers? Who would disagree? Okay, so all integers are rational numbers. Okay, so it doesn't matter whether is it positive or negative. You can have positive rational numbers, you can have negative rational numbers. Okay, you can also be talking about positive integers, negative integers. Integers generally seem like the whole numbers, okay, but then you have the negative portions as well. But despite so, they can also be expressed in a fractional form, just that the denominator is 1. Okay, so therefore, in this case, yes, I is a proper subset of H. And the reason for that is that all integers are rational numbers. With the definition of a proper subset that we learned yesterday, that all elements of I would be also in H, and then also I is not equals to H. So that is why it is a proper subset. N is a set containing A, B, C, and D. Okay, so could I give you maybe about 2 minutes to write out all the proper subsets that are possible out of this set? Okay, let's check our answer. I remember yesterday we also did something similar and we stopped at Alia and Ning. So let's start from Majia. Can you tell us the first proper subset that you have?
Noun set.
The noun set, okay. Next, Amanda. Set containing A. And then answer? B, okay. Containing B. And then, C, okay. And then Jared, set containing D. And then Junyang, containing A, B. And Joanne, AC. And Nicole, containing A, D. Is it? Okay, then after that, Emily, BC, followed by Kelly, B, D, and then Bernice, CD, okay, and then Chloe, AB, ABC, okay, and then after that Charmaine, ABD, and then Joshua, BCD, okay, and then Charmaine, not Charmaine, Carissa, sorry, CDA, okay, that means ADC, okay, ADC, ACD, okay, then after that Joshua asked already, right? Then Joseph, any more? No more? Are we agree? Do you agree that this is the full list? Okay, so let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, yes. Okay, so when it comes to proper subsets, okay, this would be the full list. Okay, one trick that you could you can learn, okay, in terms of ensuring that you have the correct number of proper subsets is that, okay, to know how many subsets, okay, so given any set, okay, that has n elements, okay, n number of elements, alright, so the number of subsets will always be 2 to the power of n, and then the number of proper subsets will be 2 to the power of n minus 1. Okay, this is just some trick that you could learn to actually check. Alright, regarding why 2 to the power of something, I will not go into it in detail. Okay, but I would like to address why is it that proper subsets is always 1 less than number of subsets. Why would proper be 1 less than it? Can you tell me what is actually missing if I change the question to finding number of subsets? What will be the last one? A, B, C, D. Okay? Why would it be A, B, C, D? Because when we talk about subsets, okay, the difference between subset and proper subset is that in subset, there is that possibility that they are equal, right? So therefore, ABCD is equals to ABCD itself, right? And that is a subset of the set that we have. Okay, so that's why proper subsets is always removing this one. Okay, so in this case, there are 4 elements. So the number of subsets should be 2 to the power of 4, which is 16. And the number of proper subsets will be 16 minus 1, which is 15, which is correct. Okay, any questions? Alright, so now let's look at question 10. Okay, we are given the universal set x to be a positive integer lesser than 21 and O to be a number divisible by 3. We want to list all the elements in O prime, which is O complement. So what would the elements be? Joseph? Continue. Can you tell me what are the elements in O complement? 1, 2, 4, 5. Okay, oh, okay. 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, 19, and 20. Alright. It may not be easy to actually list out all the elements in O complement directly. Okay, so what you may want to do first, okay, which actually is usually my habit as well, that I will list out all the elements in the universal set first. That I'm talking about all the elements from 1 all the way to 20. Okay, and then after that, for the set O itself, you have numbers divisible by 3. So looking at the elements that you have in the universal set, that will be your 3, 6, 9, 12, 15, 18, and no more. 3, 6, 9, 12. Yeah. Okay. Then after you look at the universal set and the O set, okay, then you can know what are the elements that are not in the complements, not in the O set, but in the complement set. So those are the things that are not found inside here. Okay. Otherwise, if you just try to think and write at the same time for the complement set, you may get lost in it. Okay. Now in part 2, we want to describe the elements in the complement set in set notation. So how would you describe it? Yes, Dylan? Sorry? Okay, and alright, let me write that down. Okay, so Dylan says that O prime is a set because the question wants it to be in set notation. Okay, so where X are the elements, X is a number, is it? Integer. A positive integer less than 21 and not divisible by 3. Okay? Will that be okay? Right? This is a good definition, okay, good description of the set, of the complement set. Okay. However, because in the question itself, it has already defined for you the universal set. So the complement set will naturally be bounded by the universal set. Likewise, O is also bounded by the universal set. So you need not actually go into saying that X is a positive integer less than 1. So you can just say that X is a number not divisible by 3. However, even if you write what Dylan has said in exam, there's nothing wrong with it as well, still will get the mark. Okay? Just that you may want to know that you can also write it in this manner. Okay? So in this case, in case you're wondering why this time around I can say that it is a number, why can't I use the word, why do I want to use the word integer unlike previously? Okay? This time around I'm accepting the word number because like what I mentioned earlier, okay, the universal set already states that it must be a positive integer. So the sets O and also O prime, O complement, they are bounded by the fact that they must be positive integers already. So you need not go and emphasize on it again. But then of course, if you want to put in the word integer instead, that is also perfectly fine. Okay, because it will also still be bounded by this universal set. Any questions? Okay. If no questions, then for exercise 1B homework, okay. just write it here. Question 4, 5, 7, and 9C. Okay, when is it due? Monday or Tuesday? Monday? Tuesday? Monday, okay? Oh, okay, can. So, 16, 17, 18. Okay, next we move on to 1.3 and 1.4 today, where we're going to look at intersection and union of two sets. Okay, so in 1.3 we're going to be looking at intersection, right? Where I'd like to get you to consider these two sets first, okay? Where A contains the elements 1, 2, 3, 4, 5, and B contains elements 3, 5, 6, 7. Okay, so how do we go about drawing this Venn diagram? Earlier on we have seen how to draw Venn diagrams involving the universal set, okay, containing one set itself. Otherwise, it would just be one set inside another, okay, where they are proper subsets. Okay, so now if I want to draw this Venn diagram, we notice that there are some elements that are actually overlapping, and that will be 3 and 5. Okay, so because it overlaps, so we put them in the overlap itself. Okay, then after that, if this is my set A, I will put 1, 2, and 4 here. And if this is my set B, I will put 6 and 7. Okay. Notice that previously I had the habit of putting my labeling for the set on the top left hand corner. But when it comes to overlapping in such a manner, I wouldn't put it here again. I wouldn't put it here, otherwise it would be hard to catch. That's why I would actually usually put it here. Okay, but of course, as long as your labeling is here, okay, and can be seen easily, alright, there wouldn't be any problem about where you label the set. Okay, so this is where the intersection lies, okay, because they overlap each other. That's the idea of intersection. So we will describe this intersection using set notation, okay, and this is an inverted U, okay. So this is what we call A intersect B. Okay, and to describe this entire set, it will be containing the elements 3 and 1. So do take note that writing it in this manner, okay, this itself is also a set. That's why I can write it in this manner. Okay, so very quickly, let's look at practice now 5, question 1. I'd like you to list down all the elements found in set C and set D, okay, and writing them in set notation. the elements in set C? Mervin, what's the elements in set C? Sorry? 6, 12, 18. Okay. What about in set D? Richard, what do you think? Okay, 3, 6, 9, 12, 15, 18. Okay, then after that in part 2, we want to find out what is C intersect D. So, what do you think that would actually be? Again, what do you think? 6, 12, and 18. Okay, so those are the common elements that we see. Now in part 3, we want to draw out this Venn diagram. Okay, so notice that C and D, okay, they have common elements. In fact, all the elements in C are found in the elements in D. So I'm providing to you two options. Should we be drawing our Venn diagram in this manner, or okay, is there another manner that we could draw? Would this be fine? How many of you would think that this is fine? I see Dylan, I raise a hand, then after that put at the back. What do you think? If you're not raising a hand, then how else do you think you would have drawn? Circle C inside the circle D. Okay. So, meaning like this. 6, 12, and 18. 3, 9, 15. Are we okay with this one? Or will you all think this is also fine? How many of you think this is also fine? Okay. Just to clarify, right? Because we now are very clear and can see that 6, 12, and 18 are all elements also in D, then how we should be drawing our Venn diagram should actually be like this. We should not draw it like that. If we know that this is already empty, then we shouldn't be providing a space over there. It only provides it only mislead readers to think that there would actually be elements. Okay, so we don't want to mislead readers, right? So that's why we will draw it in this manner. Okay. So actually, we can see that C is a proper subset of D. Right? So now that we have drawn out the Venn diagram, so in part 4, is C intersect D equals to C? Yes or no? Who will say yes? That C intersect D is equals to C. Who says no? How about you guys? What do you think? The question is asking, is C intersect D a set itself? Okay, if talking about intersection, is it the same as the set C on its own? Do they have the same elements? The question is asking about whether they are equal or not. Okay, because C intersect D is a set, C is a set itself. So when we talk about equal sets, okay, the elements must be the same. So then, would C intersect D be equals to C? Joshua, what do you think now? Yes. Okay? Yeah. So C intersect D is equals to C. Yes. And the reason is because all the elements in C are in D are also in D. That's all. now 5 question 2. I'd like you to list out all the elements, okay, in E and F set notation. So what are the elements in E and in F? Yang, what are the elements in E? One, 2, 3, 4, 6, 12. Right, so these are all the factors of 12. 1, 2, 3, 4, 6, and 12. What about in F? What are the elements in F? Kelly?
5, 7, 11.
5, 7, 11. Anything else? 13. Okay, since the question says that it's inclusive, so 5 and 13 are included. Right? So now we want to find out what is E intersect F. Okay? So E intersect F, if we look closely at the elements, okay, is there anything in common between these two sets? Since there are nothing in common, okay, what does that imply about E intersect F? It will be a empty set. Okay? So to explain it, alright, we can say that there are no elements in common. Between E and F. Okay, so then when we draw a Venn diagram to represent set E and F, okay, would you agree if we draw our set in this manner? 1, 2, 3, 4, 6, 12, 5, 7, 11. Will we accept this? No? Why? It is not about similar elements, there are no elements. No same elements. Okay. Same and similar different. Similar and congruence different. Similarity and congruency. Okay, so there is no common elements between the two. That would mean that there should not be any overlap. Even though you leave this area empty, having nothing listed inside, it is misleading to the reader. Okay, so just like earlier on, we should not have empty spaces if we are very clear that there's nothing inside. Okay, so what we could do instead is to actually draw the two sets separately. Okay, so this is what we call disjoint sets. Okay, so disjoint sets are basically when two sets have nothing in common. Okay, or we can also say that the two sets here in this case that we're referring to are E and F when the intersection is empty. Okay, so that is what we call disjoint set. on in the first question, we saw that if it is a subset, the intersection will be the subset itself. I mean, if it is a proper subset, to be more precise, if it is a proper subset, then the intersection will be the proper subset itself. Okay. So now with this, we're done with looking at intersection. We'll look at unions now. Considerations. Set A containing 1, 2, 3, 4, 5. Set B containing 3, 5, 6, and 7. This is how the Venn diagram looks like. Earlier on we saw that the intersection is the set 3, 5. Then for union, okay, like the word suggests, union, okay, we use the same similar symbol, the letter U, but it's a big letter, big U. Okay, this one is also a big one, same size. Okay, so A union B, right, would actually refer to thinking about how unions are like people coming together, okay, like marriages and all that. Okay, so when we talk about union, right, it is everything together. So in this case, we are looking at all the elements 1, 2, 3, 4, 5, 6, 7. Okay. So this is how we read it is A union B. Okay. So likewise, A union B itself is also a set, just like how A intersect B is also considered a set. Okay, looking at practice now 6, question 1. We have the set C, which is a positive integer, and a factor of 8. While D is a positive integer and a factor of 6. Okay, I want you to list out all the elements in the set D. C and D is set location. Okay, so could you do that now? Elements in C. What is the elements in C?
1, 2, 4, and 8.
1, 2, 4, and 8. Great. And And what about the elements in D? Alia? 1, 2, 4, 8, and 16. Okay? So, in part 2, we want to draw a Venn diagram to represent the set C and D. So, how would we draw this Venn diagram? How would you draw this Venn diagram? Joanne, how would you draw? Will you describe the drawing that you may have?
It's like a AB drawing, but the overlap part is 1, 2, 4, 8. And then the circle for D is an extra 16.
So you want to draw two circles overlapping like that, and then down here you're saying is 1, 2, 4, 8. Got it?
Wait, no. Two circles. One circle inside.
Okay, so which circle is inside? C is inside, okay, and D is outside. So 1, 2, 4, and 8, and then 16 on the outside of C. Okay. By the way, you don't have to draw perfect circles, okay. You just draw, even you draw over also okay. You can draw a circle until it becomes square. I am thankful you're not taking part. Okay. So part 3, find C union D. Okay, so what would C union D be equals to? Will you list out the sets for me first? As in list out the elements for me. What would the elements be in it? Emily? 1, 2, 4, 8, 16, right? Okay, so that will be the elements in the set C union D. Okay, you may also want to, if you can say it, okay, you may also can say that it will be the set D itself. Okay, sorry. I didn't realize that was a fourth question. Okay, so in part 4, okay, the question asked is C union D equals to D. Yes, right? Because you see that it is the entire thing, and the reason is because because all elements of C are in D. So that's why C union D would be the set D. Okay? So we notice that if there is a proper subset situation, the intersection is the smaller set just now. Okay? And if there is a union, we are talking about the entire outer set. Okay? Yeah. All the elements in D are in C union D. I think that's also fine. Okay. Adia asked if the explanation, if she explained it as yes, because all elements of D are in C. Right? That's what you said, right? Sorry, C union. This will be a acceptable explanation as well. Okay, since we're talking about equal, so if we are having C union D to be equals to D, we can have the elements inside here to be inside here. Otherwise, we can also say the elements inside here will have to be inside here. So because that's the whole idea of equal, right? Is unlike when we talk about proper subsets, okay, there is a different situation. Okay. Next, we look at question 2. Let's look at that last one for today. Okay, same thing. I want you to list out all the elements in E and F. Where X is a multiple of 7. 9, you'll use fingers, right? Anybody don't use fingers for multiple of 9? Don't use fingers for multiple. How you memorize multiples of 9? There's a song? Wow. You all know the finger trick or not? So, 1 times 9 is 9. Put down one finger. 2 times 9 is 18. 1, 8. 3 times 9 is 27. No? 4 times 9, 36.
But isn't it the left side plus one, right side minus one?
Huh? Yeah lah, you can do that also lah. Yeah. It's also fine. Anything. I always thought people always use fingers. Y'all know? No? Wow. Okay. So yeah, 9, 18, 27, 36, 45, 54, 63. Okay, so what are the elements in E and F? What are the elements in E? Shami? Elements in E? Okay, very good. 21, 3, 4, 28, and 5, 5, 6, 42, 7, 49, 8, 56, and 9, 72. Okay, then after that in your set F itself, we would have, I believe you all know it all the way from 9 to 54, right? Okay, then after that, how to draw this Venn diagram? How will the Venn diagram look like? Marvin, what do you think? How will the Venn diagram look like? Huh? 2 separate circles. So disjoint sets. Okay? Agree? It should be 2 disjoint sets. So we have 7, 14, 21, 28, 25, 22, 49, 56, 9, 18, 27, 26, 45. Oops. Okay, then after in part 3, we want to find E union F. What would that be? Okay. Alright, so it should be everything that we can find E and F, right? So 7, 14, 21, 8, 25, 22, 49, 6, 9, 8, 7, 6, 45. Okay, there is no need for us to arrange in any increasing order and all that. So if you have some OCD that wants things to be neat and orderly, please control yourself in that. There's no need for increasing order. Okay, you can, as long as you just list down everything in the Venn diagram. Venn diagram strictly no commas. Okay, strictly no commas. So just draw your circles bigger. Okay, I would suggest drawing the circles bigger rather than writing the numbers smaller. Okay, writing your numbers smaller is a very dangerous thing because sometimes it's so small cannot read. Okay, so just draw the circle bigger. I'm sure you will get more than enough space. How big the Venn diagram is? Should be. It depends on the space given in the question. Yeah, they will be writing space given in the question paper one. So surely it is enough. Then you need to pen beforehand. Okay. So we end here for today. Next lesson we'll do 1.5 where we'll do some shading of Venn diagrams. That's a slightly more fun activity. Okay, thank you everyone.